Hey folks, you might recognize my voice. This is your teacher, Mr. Keener, recording myself for your listening pleasure. In today's video lesson, we will be going over solving quadratic equations, what that means, how we do it, as well as a few examples. Periodically, the video will stop. You will answer some questions in your guided notes, and once you have finished, you will resume the video and get more learning. So without further ado, let's begin. So first, what does it mean to solve a quadratic equation? Well, to solve a quadratic equation, let's go ahead and pull one up. Y equals x squared plus 3x plus 4. Why not? This is a quadratic equation. We see our square there. It's in nice standard form. To solve a quadratic equation simply means we are looking for a value for x that's going to make y equal to 0. It's that simple. So this is why it's often called the zeros. The solutions are also called the zeros and also the roots. All right. Now there are a few ways to solve quadratic equations. We're going to go over the most basic one first, and that is using the graph. Now the graph is a representation of all of the values for x and y that one would consider solutions to the equation, i.e. if x is 4, then y is going to be negative 4. And we have 2 points right here that makes solving our quadratic equation very easy. If x is 2, y is 0. If x is 6, y is 0. These are the x-intercepts of the graph, and they are what one would consider the solutions to the graph. So we actually normally have more than one solution. Often we have 2 solutions. So the solutions are oh, that's a terrible looking curly brace, 2 and 6, and we can put it in our solution set notation here. Now, don't confuse this solution set with a coordinate pair. We're not saying that x equals 2, 6. It's not a coordinate on the graph. We can see 2, 6 is not a coordinate on the graph. 2 and 6 are simply the values for x that make y equal to 0. So we call those the solutions. So the graph is the easiest way to find them. We just look for where the graph crosses the x-axis, and that's going to tell us what our solutions are. All right, but what if we don't have a graph? Well, we also have many ways we can find our solutions algebraically. So y equals x squared minus 9. If we're trying to solve it, that means that y needs to equal 0. Yeah, circle that y real nice. All right. Okay, so x squared minus 9 equals 0. We can follow our basic steps of solving any equation. Our goal is to isolate x. So we're going to go ahead and add 9 to both sides. And we get 9 equals x squared. All right, now once we get to this point, we're looking for a value for x that when squared is going to equal to 9. You're probably thinking, oh, 3. So x is equal to 3. But there's actually another number that when squared is also equal to 9, which is negative 3, just like that. When you take the square root of 9, you get 3. The calculator is going to tell you 3, but there's also negative 3. Remember, negative 3 times negative 3, that's also going to equal 9. So sticking with our previous example, there are in fact 2 solutions to this quadratic equation as well. If you don't believe me, you can plug it into your graphing calculator and you can see that this graph is going to cross the x-axis at both 3 and negative 3. Wow, oh my God, crazy, what, wow. All right, let's get into some more complicated stuff. So y equals 3x squared plus 3x. We're going to solve this quadratic equation by factoring out the greatest common factor. And there's a reason that we're going to do this, and I'll explain it after we do that factoring. So 0 equals 3x squared plus 3x. Now, the GCF, or greatest common factor, of 3x squared and 3x is going to be 3x. That is the largest factor that we can divide both of these terms by evenly. So 3x squared divided by 3x is just going to leave us with x, and 3x divided by 3x is going to leave us with 1. So when we factor out the GCF, we're going to write it as a product of these 2 factors right here. So that looks weird. 3x times x plus 1 equals 0. Now, once we get to this point, now's a good time to talk about the 0. Oh God, that's not a great looking E. The 0, oh, what am I doing? The 0 property. Now, the zero property of multiplication states that if any of the factors in a multiplication problem are zero, then the result is zero. So that means if this is a factor and this is a factor, if we make either of these factors, this is the whole binomial is a factor, if we make either of these factors equal to zero, then the whole thing will be equal to zero. So to make 3x, I'm going to clear some space here. To make 3x equal to 0, well, we can go ahead and set that up and solve it. So 3x equals 0. Well, divide both sides by 3. All right, well, we know where this is going. X is going to be equal to 0. Now, if we substitute 0 for x into this equation, we get 3 times 0, that's going to be 0. 0 plus 1, that's going to be 1. 0 times 1 is 0. It doesn't even matter what we have in here because anything times 0 gives us 0. Now, that's all well and good. We have at least one solution, 0. But we can also make our other factor equal to 0 as well. X plus 1 equals 0. Subtract 1 from both sides. We end up with x equals negative 1. So x equals negative 1. If we substitute this into our other equation, we get negative 3 times, what do you know it, 0. Negative 3 times 0 is equal to 0. So once again, we have two solutions. Oh, I wrote that wrong. We have two solutions, 0 and negative 1. If you don't believe me, punch it into your graph. I promise you, your mind will be blown. It's going to be amazing. I punched it in for you. Maybe I didn't trust you. I don't know. I should probably trust you more. But here's what the graph looks like. And we can see clearly when 3x squared plus 3x, our graph is going to cross the x-axis at 0 and negative 1. Well, you know, those were our two solutions. Oh my God, it all works. Everything works. Math is amazing like that. And now we're going to try a new example, this time in a fresh new form for the quadratic equation, which is called factored form. I'll let you guys try and figure out on your own why it's called factored form. All right, y equals x plus 3 times x minus 2. Now you might not be thinking, hey, that's not a quadratic equation because I don't see a exponent of 2, but you're wrong, and I'll prove it. So if we do our box method for our binomials, let's take a look. X plus 3, x negative 2, we get x squared minus 2x plus 3x. I'm hoping this is tingling some nostalgic butterflies for you. X squared minus 2x plus 3x minus 6, x squared plus x minus 6. These are the same thing. We call these equivalent expressions just like that. These are the same thing. So yes, even though it doesn't look it, it is a quadratic equation. All right, let's clear everything. Now, just like in the last example, we're going to solve this by setting it equal to 0. And we're going to remember that if either of these factors is equal to 0, then the whole thing is equal to 0. So we can take our two individual factors, x plus 3 and x minus 2. And this may be confusing at first, but remember, a binomial, if it's in parentheses, we can treat it as one unit. I'm doing my best Sal Khan impression right here. X plus 3 equals 0, x minus 2 equals equations like this. We're just going to go ahead and do it to the other side. So x equals negative 3 and x equals 2. Those are the values for x that are going to make this equation true, and they're the values for x that are going to make this equation true as well. Those are our two, ooh, I missed, Control Z. Those are our two solutions, negative 3 and 2, and we can put it in our solution set notation, just like that. Ooh, remember, not a coordinate pair. This is our solution set. All right, and now we're going to move on to the pièce de résistance of this lesson, the final form, if you will. Well, not really the final. This isn't even my final form. Not really the final form. There's so many more ways to do this, but we're going to start with this one right here. This is a basic standard form quadratic equation. We're going to write this in factored form for the sake of solving the equation. Now, so in the last slide, we went from factored form to standard form by multiplying it out. This time we're going to work backwards. We have it in standard form. We want to get it in that nice factored form, a product of two different binomials. Set that equal to 0, and that makes it easy to solve. So it's going to probably look something like this, x plus something, and we're good to go. Hopefully this is a review. If not, let's really quickly recap what we need to do. So we are looking for two numbers. We'll call them a and b. We're looking for two numbers, not to be confused with ax squared plus bx plus c. But we're looking for two numbers that when added together equal 5. This guy right here. Whoops, I missed. That guy right there. And when multiplied together equal 4. This guy right here. Seems easy enough. So we can go ahead and get a list of factors. Oh, that's a terrible straight line. Let me fix that again. All right. Lines must be straight. All right. So let's do our factors of 4. And let's see what they add to. So these are our factors of 4, and these are going to be the sum. So let's start with the easy ones. Let's go 2 times 2. Well, when we add 2 and 2 together, we get 4, but we're looking for 5. That's no good. Let's go with the other one. Come on, there's only one left. 4 times 1. When we add those together, it's 5. That's what we're looking for. You probably beat me to that. So 4 times 1. So 4 and 1 are our 2 numbers. Now what we're going to do with those numbers, as we get into more complicated quadratics, there's a little bit more, but for now we're actually just going to take those numbers and we're just going to put them in the binomial form that we had earlier. X plus 4, x plus 1. Those are our 2 factors. We're going to set it equal to 0, and we're going to do the same thing we did on the previous slide. In case you don't remember, we set them both equal to 0, and then we solve. So x plus 4 equals 0, x plus 1 equals 0. Solve them both. Your solutions are going to be -4 and -1. I'm all over the place here. All right, well, thank you guys for listening. I hope you enjoyed the video. I mean, as much as one can enjoy a video of your teacher talking into a microphone about math concepts without any real-world applications whatsoever. But still, I hope you enjoyed it. And I look forward to working with you on this in class tomorrow or today, depending on when you're watching it. All right. Sayonara.